Welcome to Edify ACE, a career-oriented online training program.
Today's session is about water supply pipe sizing by graphical method. The water supply pipe sizing shall be calculated such that each wet area is supplied with the required flow, pressure, and velocity. There are various types of rooms within the building that require water supply. For example, toilets, laundry rooms, kitchen areas, car parking areas, and many more. Also, there are specialized units like pump rooms, mechanical pump rooms, provisional requirements for restaurants and retail units, and so on. Following tasks shall be performed to establish a proper water distribution network. Number 1. Identify the type of sanitary fixtures, that is, like wash basin, bathtub, shower, kitchen sink, etc. Number 2. Identify the number of sanitary fixtures within the building. Number 3. Select the appropriate flow and pressure based on the codes for each sanitary fixture. Tip to remember while performing water supply pipe sizing. There are various methods to calculate the pipe sizing. Following are the major driving factors while considering the reference guideline for pipe sizing. 1. Local authority guidelines. 2. Client MEP guidelines, which will be given by the concerned client for the project. 3. International codes accepted by the region where project is located. Following are the few international standards that can be taken as reference to calculate the pipe sizing. American Society of Plumbing Engineers, Uniform Plumbing Code, Institute of Plumbing, International Plumbing Code. In this session, we will consider Institute of Plumbing IOP as reference to calculate the pipe sizing. Before proceeding with the calculation, let us see what are the steps or process of pipe sizing. Firstly, number of sanitary fixtures shall be quantified from the project. From there, we can arrive the loading units. From the loading units, flow rate can be obtained. Secondly, pressure shall be calculated, which is based on three major factors: static head, friction losses, and residual pressure. It also relates to velocity. So comparing all these three major factors, that is flow rate, pressure, and velocity, will finally give us the pipe size. This is extracted from IOP, Institute of Plumbing. This graph is used to calculate pipe sizing. I know this graph is not clear in this slide, but in the next coming slides, you will see an enlarged clear graphical presentation of this. As you have learned from the previous slides that the first step is to calculate loading units. Each sanitary fixture from this table is assigned with different number of loading units, which is defined by various codes and standards. From these loading units, flow rates can be achieved. Step 1. Prepare a schematic diagram. In this session, let us take ground, first and second floor building with a water tank at ground floor, a booster pump, and each floor will have one wash basin, one water closet, and one shower. Step 2. Identify the number of nodes for remote path. The node numbering shall be started from the most remotest sanitary fixture and shall reach to the source point. Source point is nothing but the booster pump. The other node points shall be defined where there is a connection to the header with other sanitary fixtures. You can see in the schematic all the other node points have been defined from node 2 till node 5. Step 3. Assign loading units at each node point. Let us start with node number 1, which is shower. From the table, shower gives loading units of 3. So let us assign loading unit 3 to node number 1. When it comes to node number 2, it is a combination of shower and water closet because the pipe which is connected to node 2 is supplying to shower as well as to water closet. Means shower has 3 loading units and water closet has 2 loading units. So the total loading units will be shower plus water closet, means 3 plus 2, which is 5. Similarly, for node number 3, which is connected to shower, water closet and wash basin. So the total loading units will be 7 for node number 3. Also for another floor, the node number 4 will be connected to all the above second floor sanitary fixtures as well as first floor sanitary fixtures. Means this node number 4 will add second floor and first floor loading unit sanitary fixtures. So the total loading units for node number 4 will be 14. Finally, node number 5, which is connected to all the pipes and sanitary fixtures for all the floors, gives us total number of loading units 21. Step 4. Select flow rate based on loading units. Right side of this graph is provided with different loading units. Left side is with flow rate liters per second. In the previous slide, we have identified different loading units for different sanitary fixtures on different node points. For 3 number of loading units, which is for shower for node number 1, we need 0.15 liters per second. Accordingly, if we calculate or just identify the number of loading units on this graph and then drag this towards the left side to arrive straight away the required flow rate. Now the final loading unit based on our previous calculation was 21. So 21 loading units will give us approximately 0.5 liters per second. Step 4. Select flow rate based on loading units. We have now identified the flow rate based on each node number and loading units. Step 5. Identify the intersection point for pipe size. In this step, velocity shall be considered. Generally, in water supply piping network, velocity of 1.5 meters per second shall be considered. From this graph, brown line is nothing but a velocity line of 1.5 meter per second. So this is drawn a line with 1.5 meter per second velocity line. Let's start with the first loading unit, which is 3 for the shower, from where we have identified 0.15 lps. So from there, this velocity line, wherever it is crossing, let us point it out with red dot. Similarly, we will perform the same way for all the other loading units flow rates. Whichever it is intersecting, we will identify that point as our reference. The lines on the perpendicular side towards the velocity are the pipe sizes. You can see here 15 mm, 20 mm, 25 mm, 32 mm, 40 mm. Now how to size this? Let's take first point as reference. In this point, the flow rate is 0.15, velocity is 1.5, and this point is intersecting below this line, which is below 15 mm. Means the pipe size can be up to 15 mm. So we can define this point as 15 mm. Next point is within 15 to 20. We can take 20 mm as the size of the pipe. Similarly, we can perform in the same way for all the other points. Step 5. Identify the pipe size on each node. Since we have already know the pipe sizes from the previous graph, let us put the same on this schematic diagram to each node number. From node number 1 to 2 is 15 mm, node 2 to 3 is 20 mm, from node 3 to 4 is 25 mm, node 4 to 5 is 32 mm, node 5 to the source node, which is from the pump, will be 32 mm. I hope you find it informative. If you have any doubts related to any of the slides, for example, like identifying the node numbers, loading units, flow rates, how to calculate the pipe size from the graphical method which I have shown here, or you want to have any other more methods to calculate the pipe sizing, then please do drop me an email on edifyace@gmail.com. Thank you for watching this video. Hope to see you in the next session.